So these are the last two lessons that we're looking at for Unit 2. 2.9 and 2.10 are both about parallel and perpendicular lines. So parallel lines are two lines that start in a different spot, but they have the exact same slope, so they're never going to catch each other. So if you think about the lanes on a road, those lines are parallel. They never catch each other. They always stay the same distance apart. Perpendicular lines are two lines that when they cross at a 90-degree angle. So they cross at a perfect plus sign or T, however you want to think about it. So we are going to be given information and asked to find the equations of lines that are parallel to each other and lines that are perpendicular to each other. So to start out, the first thing that we need to know is that parallel lines have equal slopes. Their slopes are the exact same. So I'm going to come down here to this table, and the first thing that we're going to do is practice finding the slope that's parallel and perpendicular. So the slope that's parallel to a slope of m equals 5 is 5. The slope that's parallel to a slope of 3/4 is 3/4. Come grab a note sheet, please. The slope that's parallel to a slope of -1/2 is -1/2. The slope that's parallel to a slope of 0 is 0. And the slope that's parallel to a slope of -1 is -1. So parallel slopes are pretty straightforward. They are the exact same as the slope you're given. So if I'm asked to find a slope that's parallel, it's going to be the exact same slope. Okay. Perpendicular slopes, on the other hand, we're going to have to do a little bit more work to find those. So perpendicular slopes are opposite reciprocals. So the opposite refers to positives and negatives. So if your original slope was positive, a slope that's perpendicular to it's going to be negative, and vice versa. If you were originally negative, your new slope's going to be positive. And then the reciprocal, it's a hard word, is you take that fraction and you flip it over. So if you were 1/2, now you're 2/1. If you were 5/3, now you're 3/5. So you're going to take it and make it the opposite sign, so whether it was positive or negative, and you're going to flip it. So coming down to here, the first thing that I'm going to do to help me with my perpendicular slopes is I'm going to turn all of these into a fraction. So I'm going to put this 5/1. I'm going to put this 0/1. And I'm going to put this -1/1. So I'm turning all of my parallel slopes into fractions because it's going to make it easier to flip. Okay, so now we are ready to do our perpendicular slopes. So a slope that is perpendicular to 5/1, since it's positive here, we're going to make it negative here. And then we flip that fraction over, it's -1/5. Okay. For 3/4, since it's currently positive, we're going to make it negative. And we're going to flip it. A perpendicular slope is -4/3. Okay, -1/2. This one, since it's negative here, it's going to be positive here. So our slope is going to be 2/1 positive. Grab a note sheet. And then we can leave that as 2 over 1, or we can say it's just 2. Either of those are correct. Okay, this one right here is a little tricky. So a slope of 0 is a straight side-to-side line. If I go to find the opposite reciprocal of this, it's going to be negative 1 over 0. Am I allowed to divide by 0? No. Anybody remember what special slope this is? Undefined. Yes. So it's going to be straight up and down. It's going to be undefined. So we just wanted to throw that one on there as kind of a reminder. So that's the one like special case that 0 and undefined are perpendicular to each other. And then this last one, negative 1 over 1. So I'm going to do the opposite and make that positive, and then I'm going to flip it so it's going to be positive 1 over 1, which can just be 1. So what you guys need to know is to find a slope that's parallel. It's just the exact same thing. And to find a slope that is perpendicular, you take it, you make it positive or negative, you make it the opposite sign, and then you also flip it. Okay, any questions right now? Okay, go ahead and flip this. And what you guys are going to be doing on your assignments is what's on the back here. This was just practice to get used to parallel and perpendicular. So these are the instructions that you guys are going to get on your assignment. On the front side, you just do this part. On the back side, you do this part and you graph. So write an equation for the line that is parallel to y equals 3x plus 2 and has a y-intercept at 0, negative 1. So we are giving you the information and you are putting it in an equation. Then we are going to graph both lines. So these blanks are for us to write our new equation. So we know we want to be parallel to y equals 3x plus 2. So if we want to be parallel, we want to have the same slope. So my slope is going to be the exact same. It's going to be 3. Then I've got a y-intercept at 0, negative 1. So my new line, its y-intercept is going to be negative 1. Okay, so then we're going to put those two things together into an equation. So it's going to be y equals, my slope is 3, so it's going to be 3x minus 1. So that's the first thing that we're asked to do, is to write that equation. And then we are asked to graph both lines. So we are going to do that now. Josh, grab a note sheet, please. So I'm going to start by graphing the original line first, y equals 3x plus 2. Grab a note sheet, please. So I'm going to graph that in pink. So we're going to start at 2. So that's my y-intercept. And then my slope is 3. So I go up 3, right 1. Anytime a slope's not a fraction, I can make it a fraction by putting it over 1. In addition to going up 3, right 1, I can also go down 3, left 1 a couple times. Oh, I went off the page. And then I'm going to connect those. Okay. Then I'm going to graph my new equation that I wrote in blue, just so you guys can see which ones I'm doing. Y equals 3x minus 1. So I start at -1 on my y-axis, and I do a slope of 3. So I go up 3, right 1, up 3, right 1. Once again, if I want to, I can go down 3, left 1 a couple times as well. Okay. So these two lines are parallel. They have the same slope. They never cross each other, and they never will cross each other, even if our graph was way, way bigger. Any questions about that example? Okay, so we are going to do a perpendicular example then. So the next example says write an equation for the line that is perpendicular to y equals 2/3 x minus 1 and has a y-intercept at 0, 4. Then we are also going to graph both lines and see that they are perpendicular. Zoom into this a little bit. So for perpendicular, there's one extra step at the beginning because it's not just the same slope. It is the opposite reciprocal. Grab a note sheet, please. So you're going to take that number, that 2/3, you're going to flip it over and make it 3/2, and you're going to make it negative. So my slope is going to be -3/2. And then my y-intercept is 0, 4. So putting that in an equation, my equation is going to be y equals -3/2. Come to the note sheet, please. X plus 4. Okay. Any questions about writing that equation? Okay. Then we can go ahead and graph both of them. So we've got y equals 2/3 x minus 1. I'll graph that one first. That's our original equation. We're going to start at -1. Zoom out. And graph a slope of 2/3. So start at -1. Graph a slope of 2/3. So we go up 2, right 3, up 2, right 3. And then just because I like to make my lines go all the way across my graph, you could connect those with a ruler at that point pretty easily. I go down 2, left 3 a couple times. Okay. Then to graph the other one, I'll graph the second one in blue. So we'll start at +4. And my slope is -3/2. So I'm going to be going down 3, right 2. Down 3, right 2. Down 3, right 2. And I just do it on the same coordinate plane and connect them. And they should, if everything is set up correctly, they should connect at or cross at a 90-degree angle. Which it looks like they do. So the reason why we're having you guys graph these at the end is to check yourself essentially. Because if these two lines never cross, that means we successfully graphed two parallel lines. If these two lines cross at a perfect 90-degree angle, a perfect right corner, then that means we successfully graphed two perpendicular lines. Okay, any questions right now?